to our lecturer and fellow student. So my name is Muhammad Kamil Effendi and I'm from Group G. So today I will explain application of multimeter to measure current and voltage for capacitance, resistor and inductance.
Hi, my name is Wana, B1125100340.
Okay, this is for circuit 1. First, I selected the required components such as resistor. This is supply. Okay, then for measure current, I take the multimeter. Then I connect wire V1 to R1. This is for measure current. Then I take again multimeter. I connect wire to R1, positive and negative too. Okay, then I also check the component value to make sure they match the given specification. So SMM1 for current change to A and SMM2 for voltage. Circuit 2, we just repeat the same step like circuit 1, but we adding a capacitor in this circuit 2. Okay, so connect the wire and take the multimeter at R1 and C1 to measure the voltage. Okay, and check the value for each component. Okay, then we have two ways to measure a current. Okay, we first this we take a probe, and that's the current and voltage value for circuit 2. For circuit 3, repeat the same step like circuit 2, but we remove the capacitor and adding inductance. And connect the probe multimeter wire to L1 and R1 to measure voltage, and take a probe to measure a current. And that's the value voltage and current for circuit 3. Voltage value is equal to 0 because inductance has a short circuit.
Next, in real life measurement, we use multimeter brand Kyoritsu model 1009. To measure DC voltage, we rotate switch to DC voltage button.
For the measure current, we use this one, milliamp or ampere. So usually for the DC current, we get milliampere. So
next, we will construct the real lab and discuss to set and take all components properly before measure them.
Assalamualaikum and good morning to our lecturer and fellow students. So my name is Muhammad Kamil Effendi and I'm from Group G. So today I will explain application meter to measure
Next, we will measure voltage current for three circuits with different components. Okay, first circuit is resistor circuit. For the component and value we use is DC supply 5 volt, resistor 200 ohms, capacitance 1 microfarad and inductance 1 henry. Second circuit is capacitance circuit and third circuit is inductance circuit.
Okay, bismillahirrahmanirrahim. So for the first circuit, we need to measure the voltage and current and the resistance. Before we measure the voltage and current and the resistance, we need to calibrate first. Like this one, and then the probe need to touch each other like that. This one. For measure the voltage, we put from the DC supply, which is the positive probe, into the positive resistor. This one, and then for the negative probe, we put to the ground of the resistor. So positive probe we put at the positive resistor, which is the negative probe we put at the ground. So the multimeter will show approximately 10 voltage between 9.98 like Multisim. Multimeter we put the milliamp. Okay, so to measure the current at the resistor box, we need to break the circuit, which is we put the positive probe. Then we need to take the digital multimeter into the circuit, which is we put the positive probe into the digital probe, and then negative probe multimeter we put at the positive probe resistor. So we will get around 50.3 milliamp like the Multisim circuit. So I will pass to the Afif Jalil for explain the circuit 2.
Now I will explain for the circuit 2 that we need to measure the voltage and current for the resistance and the capacitance. Now I will measure the voltage for the resistance. As we can see, the value is 0 because the current that going through from the DC supply is been charging at the capacitance. That's why the current does not go into the resistance. Now I will measure the voltage for the capacitance. Voltage for the capacitance is 10 volt. Same as the voltage output from the DC supply circuit. First thing first, we need to put the multimeter here for the positive side and here for negative side. As you can see, the measured value for the current in the circuit is 0. Why? Because the capacitor is fully charged, and when the capacitor is fully charged, they have no current flow in the circuit. I will demonstrate how to measure voltage and current for the initial circuit. Now the positive of the multimeter going here. Here is the input for the resistor, and then it's through the output to the inductor. So we need to put the positive side of the multimeter here, and then the negative is going here. Okay, we will get 3.224 volt. That's the measured value for the resistor, and then that's voltage. Take the voltage. Using the multimeter, we need to put the positive side here, and then the negative side, and the output of the inductance, and we will get 6.7 volt. Okay, now using this circuit, we need to make it open circuit. Negative side going the output of the resistor. Now, like you can see, the value is negative. So we conclude that the value of current for the resistance and inductance is 0.
Morning to everyone, I'm Salvi. Today I'm going to be discussing on the simulation value and lab value. This is circuit number 1, comparison value of simulation and lab. We also calculated the percentage of error using the formula below. The measured value minus theoretical value divided by theoretical value and times with 100%. So as you can see, the percentage of error for voltage of resistor is 0.2% and the current is 0.8%. The percentage of error are low, indicating the accuracy level, higher accuracy level of our measurement value. This is circuit number 2, which is the RC circuit. Let's look at the comparison. So as you can see in simulation, the voltage of resistor and the current of capacitor is very low, which is essentially considered as 0 because it has microvolt for the voltage and nano amps for the ampere for the current. This in lab multimeter has a limited sensitivity compared to computer simulation, so therefore it couldn't detect tiny nanoamps or microvolts like multisim calculates. To the meter, the circuit is simply open circuit, so it displays 0 as a value. But for the capacitor value voltage, it is quite similar, 10 and 9.99 voltage, which shows the percentage of error quite low as 10.01 voltage. Circuit number 3, which is the RL circuit. Here, for the comparison between simulation and lab, the voltage of inductor shows negative 1.776 femtovolt, which is very low. But in lab, we got a huge difference where we got VL at 6.77 volt and VR as 3.224 volt, and the percentage of error is large. We'll have the explanation on conclusion. Experiment shows that simulation are very accurate for the resistor-only circuit and the RC, resistor capacitor circuits, because these components behave nearly perfect in DC. In both cases, the lab result matches the theoretical result because the resistor stays as resistor and the capacitor, charged capacitor, acts correctly like an open circuit. However, the RL circuit failed to match because in a real-world inductor, the inductor is just a long coil of wire that has internal resistance, while the simulation assumes the inductor with 0 ohm. The physical resistance of the coil in the lab takes up the voltage and lowers the current, creating a large gap between the simulation and reality. According to this, the resistance of internal resistance from EL and added up with 200 ohm of resistor increases the resistance in the circuit, causing the current to drop from 50 milliampere to 16.24 milliampere. So that is all from me. Thank you.